Look at how simple this thing is. This would be so easy to make yourself. It's just 3 little components. Easy, easy. I think a kindergartner can make one of these. Compare that to a robot and the hundreds of bones that are involved just to make the arm of a robot. This is simple. 3 little parts. You can 3D print them. And the function, if you study this picture for like a couple minutes, you'll be like, oh, I get it how it works. So basically, fluids will get drawn between the teeth as this rotates and get pushed out, but no fluid could come back because there's no room along the walls and there's no room through the center, so fluid can only go one way. And you just need a motor to turn these gears and you're good. It's so easy. Anybody can make this. The hardest part will be to precision engineer or precision machine the gears in the case to fit snug. Like, if you look at the clearances, you want the tips of each gear to like be touching the case. So that's going to be the hardest part. I mean, it can't even have any gap here, I guess. I mean, maybe there is an allowance for 0.5 millimeter of gap. I don't know. But my gut tells me the more gap that's there, the less efficient and effective the machine will be. But I'm going to have this drive poop and pee through a homemade plumbing system. And I'm also going to have it, in the case of my homemade air conditioner, it will drive Freon so that it can create the high pressure condenser coils and the low pressure evaporator coils. Oh yeah, this is an oil pump, yeah. But if you have a gap, you would lose pressure if the teeth stop turning. But as long as they're turning and pushing more fluid in one way than the pressure being lost from fluid being able to escape out through the gaps, you should be fine. So this thing would have to run constantly if there's any gap in order to maintain pressure, which is fine, it's just a little less efficient. But yeah, if you can have 0 gap, then you can just stop turning them and maintain pressure. Any gap and you lose pressure. But it just depends, I guess, how viscous the thing is. Like Freon, if there's any gap, I feel like that would instantly really, you lose pressure. Like it'd be like instantly you lose all pressure. Whereas if you're pumping water or something, there's a little gap. I feel like you could maintain some pressure as long as the gap's not huge. I don't know. But how can you have 0 gap if it's like copper on copper? Wouldn't they just be scratching each other until there becomes a gap? I feel like the gear or the case needs to have give then. Like a hard silicone coated interior to the case would allow for a tight grip, or like a rubber interior so that they can be touching each other and pressing tight. But if it's actually touching and rubbing, wouldn't that friction over time eventually wear away whatever's on there? I feel like you'd have to have a material that can compress. If it's 2 rigid materials touching each other, you would think it'd just be scraping really loud and be really hard on the motor to turn it. So you want no gap, but you also want it to be able to rub in a way that's not damaging it. I imagine it'd have to be well lubricated. A self-lubricating plastic gear might be ideal. Or a squishy gear. The gear would need a little bit of squishiness so it can rub without damaging it. Maybe the gear should be rubber, like a tough, hard rubber, right? Should the gears be rubber coated brass or rubber coated aluminum? What kind of rubber would be ideal for a gear coating? Or what kind of plastic? These are questions I need answers to. And I've been thinking about this a lot over the past couple days. It's a real problem. The shape of this is so simple. The function is so simple. The challenge will be finding the right materials. I feel like polyethylene gears would be ideal. Polyethylene is very slippery and can handle a lot of abrasion without getting damaged. Whitewater kayaks are made of polyethylene, a really tough polyethylene. I bet that type of plastic would be ideal to create a hydraulic pump. Oh, so you're saying that they engineer it with a gap, but the gap is incredibly small? So there is a gap, so you're not scraping. You're not literally touching. But the gap is so minuscule that the amount of pressure loss when the pump stops pumping is slow, and it's over time, and it's somewhat negligible, and it doesn't damage things. And the pump just kicks on once the pressure drops below a certain amount anyways. So the smaller the gap, the more efficient the system is. See, I don't have the precision equipment to get that level of smallness of the gap with rigid materials. So I'll go for the ghetto low budget version where I use materials that can handle actual rubbing. And I'd end up hand filing it to be perfect. Because I'm not a machinist and I don't have a lathe and all that crazy stuff. I can't get like half mil clearances, all that. I mean, I've watched machinists, it's incredible. But I don't even want those tools and I don't want to use those tactics. You know why? Because most people will never own that type of equipment. And so I don't want to make cool technologies and put out videos on it where no one else can make it. I want to make technologies that are more accessible, using hand tools, using stuff that everyone has. That's, you know, even somewhat a DIY, stuff that my mom even has in her garage. I want to take away excuses. People are like, oh, I can't build that because I don't have the resources. Well, no, I'll say, you know what? You can make everything I'm making for under $100 worth of tools. So I don't want to hear excuses. I'm enjoying just looking at this picture on my computer monitor. It's so sexy. Whoever thought of this? It's a genius. I think this thing is so attractive, I'm going to print it. I have to print this. This needs to hang on my wall. It's just beautiful. If I know how to make my own hydraulic pumps and my own solenoids and all this stuff, then I can make really lightweight and inexpensive hydraulic systems for my robot. And maybe hydraulics will then become more of an option if I can make lightweight and expensive versions. If you try to buy anything for hydraulics, it's either aircraft grade or it's made for large-scale construction. You can't buy small-scale, inexpensive hydraulic systems. It doesn't exist. There's no demand for it. I want to be able to make inexpensive hydraulics. That could be a huge asset to my robotics in the future. I'm going to start out sticking to electronics, but maybe I can even add hydraulics just to enhance the strength of the electronics version of the robot. Or I'll create future robots that are really, really strong after Atom that will employ hydraulics. But the downside of hydraulics is leaks. What happens when a hydraulic machine is pushed past its breaking point? Explosions of oil everywhere, destroying the entire interior of the robot, shorting out electronics. That's kind of one of the reasons I lean away from hydraulics. The first reason was the weight and inaccessibility and cost. But if I could knock those out by making my own lightweight custom hydraulic systems, I'm still going to have to battle explosions of oil. It's just a matter of time. If you guys have ever watched the show Gold Rush, you'll see oil explosions every season. They always have it happen. Anytime you deal with hydraulic equipment, you're going to deal with huge oil spill issues. And I don't want my robot getting ruined by an oil spill just because he tries to lift something that's a little too heavy or something like that. It's too risky. So I don't know. I want to have hydraulics as a tool available to me, but the applications for it I still haven't really found. Besides, you need hydraulics basically for creating a refrigerator, and I'll be building it for that. You need hydraulics to create a bathroom system, a robotic office chair toilet system needs hydraulics. So I'll be using it for that. But as far as robotics muscular systems through hydraulics, that part I'm still not sold on completely. But I want to keep it in mind as a potential. Maybe I could encapsulate all of the hydraulic systems in bladders, so that if the hydraulic systems blew up, it'd be caught in bladders and isolated from the electronics, so that it caused no massive damage from the explosion of oil. That would be a workaround. So I could definitely consider something like that. That's a really good way. I want to be able to make gears, though. I like the picture I showed. I want to actually trace that picture and print it out with the 3D printer. And see if it works. You know what I could do? Oh, what if I got a multi-head 3D printer? And I 3D printed the interior of the gear in ABS, really solid. And then the exterior of the gear, I 3D printed with NinjaFlex. NinjaFlex has compressibility. So if it's rubbing, the NinjaFlex can handle that type of abrasive action, unlike metal on metal, which would scrape loud. This would just kind of move out of the way. So it'd be, picture like a stretchy rubber rubbing on flat metal, smooth metal. It would just kind of slide along it, like nothing would get damaged. Especially if you had some lube. And I think Freon and an AC system would have some degree of lubrication. Doesn't it come with lube in it? Well, not really like tires, because tires aren't rubbing. Unless if you're peeling out. You'd want a non-grippy rubber is what I'm saying. A slick rubber. So the opposite of tires. Tires are designed to grip. You want something that's not going to grip so that it can just be a press fit without causing any damage. I think NinjaFlex would be perfect. I think it's not very grippy. I could be wrong on that. Even if it was grippy, if you coated it in silicone grease, I bet that would make a great gear because it could be a snug fit against the outer casing of the hydraulic pump without like tearing itself apart over time. Okay, yeah, I would buy the R232 cans or whatever, the standard ones. I have some already actually. But I don't even think you need that. Like, okay, the case for my hydraulic pump. I mean, first of all, so we can visualize what I'm talking about, let me pull that picture back up. So basically, these gears would be ABS coated with maybe a 2 millimeter layer of NinjaFlex. And the ABS and NinjaFlex can be 3D printed together if you have a dual filament extruder for a 3D printer. And the NinjaFlex would allow for there to be zero clearance between this wall, which will be made of molten copper poured into a mold, and the gear itself. There could be zero clearance, and so the NinjaFlex would just compress. It would compress, and there'd be just a tight fit, and it would just drag along the wall. But because the wall's smooth and the NinjaFlex could be slick, if you coated the NinjaFlex in some silicone grease, these would just rub forever without ever damaging the wall or the gear. Even something like a PVC gear, I feel like would eventually rub itself until there's more and more clearances. But even if it did rub itself and thin itself out, wouldn't it just stop thinning itself out once the gear became exactly perfect? It's almost like the walls of the case would sand it down for you until there's no rubbing at all over time. Like eventually the gear would get worn out on all the gear tips to be the perfect size. So that actually would help. Plus right here, the gap here, if it's all NinjaFlex on the exterior of the gears, these would be a pinch fitting. And since it'd be slippery and lubricated, they'd pinch and be tight together. So I feel like having a rubber coated gear is perfect, as long as the rubber's not really grippy and prone to tearing apart. So it has to be a high tensile strength, non-grippy rubber, almost a plasticky rubber. And I feel like NinjaFlex would be exactly that, a plasticky rubber that is very strong in tensile strength and very high shear strength. I sound like an engineer using these engineering terms, but we all know I'm just a wannabe. I feel like you can change the shapes of the gears all you want, but it won't change anything. Does that make sense? Like, if you compare these gears, okay, so you have fewer gear teeth now, but the total volume of fluid being moved now is only one tooth, one packet is sent at a time, just one packet at a time. Whereas here, you're getting 2 packets. Actually, I think if you look at these 2 pictures, this gear has more volume of fluid moving at once. Watch. Just sheerly based on the picture, I think that amount of volume is actually smaller than these 2. Because these gears are deeper, and there's 2 groups. So that's like, yeah, it's more fluid than that. Now, could these lobes be carved out more? Maybe. But that might affect how they grip one another if you start carving into it like that. I just think something like this is a little better. I tried drawing a simpler 3-geared system yesterday or 2 days ago, And it did look a little bit more like that lobe example, but I don't think it'd work as well. I think it'd be lower volume of fluid being moved. But I think it's cool and interesting to see that there are all sorts of different gear shapes you can go with. But yeah, I don't think the lobe shape is any better. I don't see an advantage. Oh, the larger shape between the teeth allows it to pass larger material. I got it. So that would be better for like an ejector pump, or for a pump that actually moves poop. But I feel like the poop shouldn't be hard anyways. There shouldn't be like any nuggets. Like the biggest chunk in poop should be like a corn kernel. So I don't think that's going to be an issue. The poop should be soft. And then obviously with Freon, for a pump like that, to build the pressure in a Freon air conditioning system, that would be a non-issue as well, because that's just a gas slash liquid. So no, I don't think there are any cases where I'd be worried about larger chunks. Usually you're going to be using it for hydraulic systems, passing oil or passing water in a pump system, like for water cooling. Or, I don't know, like the thickest material we'd ever use this type of pump for would be actual poop. And that's going to be soft. Even thicker fluids, I feel that they would be able to pass through. The Photoshop example I just showed, because those teeth aren't like really fine precision gears. Like they've got some nice gaps, especially once you blow that picture up and make it big. Because the actual final will be like this big, so the gears are going to be pretty substantial. There's going to be, you know, like the size of my finger between each gear, and that's more than enough to pass a fluid, no matter how thick. So I think it'll be fine. I mean, I can visualize fluid passing through a gap that big, no problem. It's fluid. Even if the gap was really small, the fluid would still pass. But yeah, I guess a lobe system, in theory, would be superior for very thick and very viscous fluids. So like, let's say you wanted just a pump that pumps peanut butter all day, like actual peanut butter. Maybe it'd be more efficient as far as the amount of motor power required to turn and suck the peanut butter through the pump if it were lobe style, because that's so thick, and if it's pumping peanut butter the entire day, I mean, it would just take more energy to force that peanut butter through smaller teeth. So a lobe system would maximize on the size of peanut butter per turn in the same cavity. The more viscosity, the more shear force is required to grab a little chunk of peanut butter and send it through the teeth. So the bigger the gaps between teeth, the less of that shearing is required, because it's like one scoop instead of lots of little scoops, and each scoop has a cost because of the amount of shear strength imposed on the motors of the pump. Baby, they see you!